In this video, I want to talk about the cross product just ever so briefly. And the cross product is the second way to multiply two vectors, and it gives you a vector back. Okay, so I'm just going to pick two vectors, and we're going to let A have components 2i plus 0j plus 0k, and B have components 0i plus 3j plus 0k, and I want to cross A into B, or what we say A cross B. All right, so the cross product is the determinant of a 3x3 matrix, okay, where the top row is the unit vectors, the second row is the components of the first vector, and the third row are the components of the third vector. All right, so if you recall, one way to find the determinant of a 3x3 matrix is to look at any of your elements along a row or column. Right? And if you take an element and you look at its row and its column, so I'm going to look at the element I here, or the first unit vector, and then I ignore everything in that row and column. And I take the determinant of this mini matrix right here. And what I do once I find the determinant of that matrix, I multiply it by the element whose row and column I was looking at. And so what I'm going to do is I'm going to take the determinant of this 4x4 matrix and then multiply it by the component I, or the unit vector I. So if you recall, the determinant of a 2x2 matrix is you multiply the top left by the bottom right, and then subtract the product of the bottom left by the upper right. And so what we get is 0 times 0 minus 3 times 0, which is 0, so I get 0 minus 0 for my ith component. And then if I do the same thing for j, if I look at j, then I'm going to ignore I and k, and I'm also going to ignore 2 and 0, or I'm not going to ignore 2 and 0 this time, I'm going to ignore 0 and 3. So I'm going to take the determinant of this matrix 2, 0, 0, 0, which 2 times 0 is 0, and 0 times 0 is 0, so the difference between those two products is also 0. And then if I look at k, I'm going to ignore I and j and this 0 and 0, and I'm going to look at 2, 0, 0, 3. And so 2 times 3 is 6, minus 0 times 0 is 0, so I get 6 minus 0 in the k direction. So the net cross product has a magnitude of 6 in the k direction, or in the z direction. And if you think about it, this makes sense. Based on what we said earlier, A cross B is equal to the magnitude of A times the magnitude of B times the sine of the angle between them. Well, if you notice here, this vector is along the x direction only, this vector is along the y direction only, so they're going to be perpendicular, so the angle between these is automatically 90 degrees, and so the sine component goes to 1, and then A cross B is just equal to the magnitude of A, which is just 2, times the magnitude of B, which is just 3, so this gives you a magnitude of 6. And then, if you apply the right-hand rule, if we let the x direction come out toward you and the y direction go to your right, then if I take A cross B, then A cross B is going to be in the up direction or in the z or k direction. So either way you do it, you're going to get the same answer. But that's how you take the cross product of two vectors.